If you are closely following AI advancements, you must have heard about the new buzzword, artificial general intelligence. We're barely catching our breath with artificial intelligence, aren't we? It once felt like a distant sci-fi dream, but now it's churning out essays, composing music, generating mind-bending visuals, and even cracking complex code. We're truly in awe of what AI can do. But while we're marveling at that, the minds building this future are already obsessed with AGI, artificial general intelligence.
So this raises the question, is artificial general intelligence just the latest tech hype, a fancy new buzzword for something we already have? Or are we truly on the cusp of building something fundamentally different from all the AI that came before? A truly adaptive, reasoning mind, not just a magnificent calculator or an incredibly sophisticated mimic.
Today, on Neural Reflections, we're cutting through that noise. We'll demystify AGI, explore its true capabilities, see who's racing to build it, and gaze into a future where intelligence might not be exclusively human. This is Neural Reflections, slow thoughts for fast times, on AI, productivity, and internet culture. I'm Jay, and joining me as always is the brilliant Maya.
Thanks, Jay. It's great to be here. So let's hit pause on the hype cycle for a moment and really define our terms. We throw around AI a lot, but most of what we interact with daily, your smartphone's voice assistant, image generators, even the recommendation engine on your streaming service, that's what we call narrow AI, or artificial narrow intelligence.
Exactly. Think of narrow AI as a highly specialized tool. It's brilliant, often superhuman, at one specific task or a very limited set of tasks.
But wait, Jay, I hear you say narrow, but then I think about ChatGPT or Gemini. They write articles, compose music, do research, crack complex math, generate computer code, interact with me in so many ways. How is that narrow? It feels pretty broad to me.
That's a fantastic question, Maya. And it's where the definition can get a little tricky and frankly misleading if we're not precise. You're right, models like Gemini are incredibly versatile. They are multimodal, meaning they can process and generate information across different types of data, text, images, even audio. They have many specialized skills in one package.
Yeah, like a digital Swiss Army knife.
Precisely. But here's the core distinction. Their intelligence, as impressive as it is, still operates on sophisticated pattern matching and statistical inference within predefined domains. They've learned to manipulate information based on immense datasets to mimic human output across various tasks. They don't possess genuine, flexible understanding or causal reasoning across arbitrary domains without being specifically trained for them.
Okay, so it's not about how many tasks they do, but the fundamental way they understand and learn. It's skill operating within the bounds of its training. So what can AGI do then that today's powerful ChatGPT or Gemini cannot? That's the real leap we need to understand.
Exactly, Maya. That's the million-dollar question, and it's critical. Imagine AGI, or artificial general intelligence. AGI isn't just brilliant at specific tasks. It's designed to be generally intelligent, much like a human. If you gave an AGI a story prompt, it wouldn't just write based on learned patterns. It could, for instance, spontaneously decide the detective needs a quirky sidekick for character development, or introduce a subplot about environmental decay because it understands broader themes like ecology, human nature, and societal impact, even if not explicitly prompted.
Wow.
It improvises, understands nuance, and applies knowledge from across all domains. And with a math problem, an AGI wouldn't just solve it. It might pause, question why you're solving this specific equation, suggest alternative mathematical approaches it learned from studying theoretical physics, or even decide the problem itself is ill-posed based on real-world constraints it deduced from reading engineering texts. It grasps the underlying principles of mathematics.
So AGI would refuse to help me with math homework then?
Not exactly refuse, Maya. It would help you, but it might first challenge your assumptions or explain how that specific problem fits into a larger mathematical framework you hadn't considered. It's about genuine understanding beyond just calculation.
This is the key. Current AIs are specialized tools. AGI would be a universal mind. It moves from specialized task doers to universal problem solvers. It's the general in general intelligence that makes all the difference. It's not just about more data or more modes, it's about genuine understanding, adaptive reasoning, and cross-domain knowledge transfer in a way current systems simply don't possess. That's why the AGI conversation is so profound.
Fascinating. So, if we ever do get close, how do we even test if a system is a true AGI, beyond just chatting with it like the old Turing test? Are there specific criteria defined or ways to differentiate a very capable LLM posing as AGI versus the real deal?
Excellent point, Maya. The Turing test, devised by Alan Turing in 1950, proposed that if a machine could converse with a human in text and consistently fool the human into believing it was another human, then it demonstrated intelligence. But this test, while historically significant, is definitely insufficient now. As you said, a super smart LLM can fool us by mimicking conversation. Researchers are proposing far more robust tests that probe true understanding, adaptability to novelty, and cross-domain knowledge transfer in a way current systems simply don't possess.
Like what? Give us a taste.
Well, there's the coffee test, proposed by Apple co-founder Steve Wozniak. It's playfully simple. An AGI should be able to walk into an unfamiliar house, figure out how to make a cup of coffee, and then successfully make it. This seemingly trivial task requires genuine understanding, not just programming. It needs common sense to navigate an unknown environment, find components like the coffee maker and water, and perform a sequence of actions in a completely novel context.
Wow, that's clever. That's wonderfully intuitive. It's about context, isn't it? Not just make coffee, but make coffee in this house.
Exactly.
So, like, can an AGI truly moderate a YouTube chat section, filter out bots and frauds, and actually stop fights because it understands the intent behind the words, not just the keywords?
Exactly. That's a perfect example of AGI's causal and common sense reasoning at work. A current AI moderator might flag certain keywords or patterns of abusive language, but an AGI would understand the nuance. It could differentiate between sarcastic banter among friends, genuine harassment, or a bot attempting social engineering. It would grasp the social context, the causal chain of how a comment might escalate a conflict, and intervene intelligently to de-escalate, not just block based on rules. It would understand the intent of a bot, not just its script. That's the crucial why that current systems struggle with.
So it's about discerning genuine human behavior versus something automated or malicious?
Yes. Beyond these specific tests, organizations like Google DeepMind are also developing broader frameworks. They're not just testing what an AI can do, but also looking for deeper signs, like whether it shows independent action, or tries to influence a situation, or even demonstrates self-preservation. They also pose what they call hard exploration problems, environments designed to push current AI to its limits, requiring truly novel problem solving that AGI should handle with ease.
Fascinating. So the key differentiator in all these tests isn't just about more data or more modes. It's about the shift from pattern matching and interpolation to extrapolation, true understanding, and genuine adaptability to novelty across completely different domains. That's the real leap. So we've talked about what AGI is and how we might test for it, but who is actually building this future? What's going on in the labs of these tech giants and ambitious startups?
It's a fascinating landscape, Maya. The pursuit of AGI isn't a single unified path. It's a frantic, often competitive race with multiple contenders, each with their own unique philosophy on how to get there and what it means for humanity. We're talking about the Titans: OpenAI, Google DeepMind, Anthropic, XAI from Elon Musk, and Meta AI. Each one believes they're on the path, but they're taking very different routes.
That's a lot of big names. How do their philosophies differ, and how do they envision actually achieving this generalized intelligence that seems so elusive?
Excellent question. Let's break down their core approaches. First, a dominant theory you hear constantly is the scaling hypothesis. This is the belief that AGI will emerge simply by making current AI models, especially large language models and multimodal systems, vastly bigger. Think more data, more computational power, more parameters. The idea is that beyond a certain scale, new intelligent behaviors will simply emerge. It's almost like if you make a calculator big enough, it suddenly decides it wants to write poetry.
So bigger is better, and this is what OpenAI and Google DeepMind seem to be betting on, at least in part.
Precisely. OpenAI, of course, is perhaps the most publicly visible, known for ChatGPT and DALL-E. Their philosophy, stated in their charter, is to ensure that artificial general intelligence benefits all of humanity. They prioritize building safe AGI directly, but also commit to assisting other aligned projects. Their core approach heavily leans on this scaling hypothesis, pushing the frontier of model size and capability combined with iterative deployment.
And Google DeepMind, a powerhouse in AI research known for AlphaGo, AlphaFold, and Gemini, are they on the same page with scaling?
They also embrace scaling, but with a significant philosophical emphasis on responsibility and preventing harm. Their approach is a blend of scaling and what they call fundamental architectural breakthroughs. They're not just making models bigger, they're trying to figure out new underlying ways AI can learn and reason. They focus on creating universal learning systems inspired by neuroscience. Think reinforcement learning, unified agents, and a strong emphasis on controlled, interpretable, general reasoning.
So they're not just about the size of the ladder, but building a better way to climb it. What about Anthropic? I know they're big on safety.
Instead of just giving an AI human feedback on what's right or wrong, they train AI models to follow a set of explicit, human-articulated principles like helpful, honest, and harmless, almost like giving it a built-in moral compass. It's about aligning AI behavior directly to human intentions.
That makes sense. It's like building the guardrails before you let the super fast car on the track. And then there's XAI, Elon Musk's venture. What's their unique take?
XAI's philosophy, as stated by Musk, is to understand the true nature of the universe and develop a maximum curious and truth-seeking AI. Their approach is a bit less conventional, building new foundational models like Grok from scratch, with a focus on real-time understanding and perhaps a more exploratory, less constrained development path. They are famously less focused on immediate commercial applications and more on fundamental understanding.
That's a fascinating contrast. Some building in secret, others opening everything up. So, given these different approaches, it brings us to the ultimate question. When is true AGI coming?
This is where opinions diverge wildly, Maya, and it's where the conversation gets truly exciting and a little speculative. There's no consensus. Estimates range from years to decades.
So Jay, in this episode, we've taken a deep dive into AGI, what it is, how it differs fundamentally from even the most advanced AI we have today, and the fascinating ways researchers are trying to build and test for it. It's clear that true AGI represents a monumental leap, not just an incremental improvement.
Exactly, Maya. We've explored the diverse philosophies of the titans leading this race, from those scaling current models to those pursuing entirely new architectural breakthroughs, all striving for that elusive general intelligence. The implications of AGI for science, for society, for even our very purpose as humans are vast and truly deserving of their own dedicated exploration. So we'll be diving into the incredible future applications of AGI and the critical ethical questions and societal impacts that come with it in a separate upcoming episode.
Perfect. So that wraps up this installment of Neural Reflections. What are your thoughts? Do you believe true AGI is just around the corner or still a distant dream? What breakthroughs are you most excited or perhaps most concerned about? Let us know in the comments below.
Don't forget to subscribe to Neural Reflections for more slow thoughts for fast times on AI, productivity, and internet culture. If you found this discussion insightful, please like this video and share your take with us and your friends.
This episode was compiled based on extensive research and various public sources. You can find links to all our sources in the description of this podcast. Opinions expressed are our own.
Until next time, I'm Jay.
And I'm Maya. And this has been Neural Reflections.